Question 6 then, transformations of graphs of functions. Here you appear to have the graph of a negative cubic function without its interesting points given, simply where it cuts the axis, which under certain transformations will float into space uninterestingly. Well, there are 4 points to get transformed. The first transformation is this, which says, now, x is the input number, f is the function acting on it, so f of x stands for the answer that you get, and this is a picture of the original answers f of x. This simply says your new answers will be double your old answers, but still at the same position x. So if I want to find the answer at 0, it will still be the answer at 0, only doubled. So that would go to 0, but 2 times 4. That will still be at 3, but the answer will be 2 times what it was to begin with. That will still be at 6, but the answer will be 2 times what it was to begin with. This is a bit tedious. Still at 9, the answer will be 2 times what it was to begin with, which means the new answers are going to be 0, 8, 3, 0, 6, 0, 9, 0. In other words, the graph is simply going to stretch to twice its height without moving at all sideways or deforming at all sideways. Like this. But it's the same in the x direction, but stretched to twice the amount in the y direction. Now for part B, y equals f of negative x. Now notice f, there's no change to the answers, it's simply where you find these answers that's changing. This says if I want to plot my answer at a certain point x, I'll have to go to the negative of x to find the answer to bring there. So if I want to plot the answer at 3, for instance, I'll have to go to negative 3, take its answer and bring it over to it. If I want to plot the answer at 6, it won't be this one. To plot the answer at 6, x equals 6, I'll have to take the answer from negative 6, which is over here, and bring it back to it, and vice versa. In other words, what happens in this case is it's going to flip over. Whatever way round I've got my original answers, these answers are going to transfer over to here. So that would form the new graph of it on the opposite side, like this. Or I could simply work out the new points by doing the exact same thing, by saying this. Well, the answers aren't changing, so that'll still be 4, that'll still be 0, that'll still be 0, and that'll still be 0. It's just that to get this answer, I'll have to go to the negative of it to find it. That'll still be 0. But I'll have to go to negative 3, that'll have to go to negative 6, and that'll have to go to negative 9. For part C it was, what about the graph of the negative of f of x? Well, this time x is staying in the same position. If I want to plot the answer at x, I'm just taking the answer that originally was at x, so the first numbers aren't changing. So if I want to do this bit first, it'll still be at 0, it'll still be at 0, so it's 3, it'll still be at 6, it'll still be at 9. But the answers will be the negative of the answers that you find there. So whatever answer I found at 0, which was 4, I'll now have to plot the negative of it. Whatever answer I found at 3, it'll still be plotted at 3, but I have to find the negative of it, but zeros of course will just stay the same. So those would be the new points. Or if you like, for this one, it means that my answers are simply going to turn into their negatives. The graph turns upside down about the x-axis. Like this. In D, I'm going to plot the graph of f of x minus 2. And that simply says, at x, I'm going to take x's answer. There's no change to the horizontally. I'm going to take its answer, but subtract 2. So at 0, I'm still going to plot it at 0, but whatever answer I had originally, I'm going to take away 2. So it'll be 4 take away 2. At 3, I'll still plot it at 3, but I'll take its answer, the y coordinate, and take away 2, and so on. So it'll be 6, 0 take away 2, and 9, 0 take away 2. So the new points would be 0, 2, 3, negative 2, 6, negative 2, 9, negative 2. Or quite simply, it would be, you've got the graph, with the original answers, and all your new answers will stay in the same position but be dropped down by 2. So it'd end up looking like this. Like this, where I haven't bothered putting those particular numbers in because they're just floating uselessly in space. They're not interesting points. They're not showing turning points, they're not showing intersection with axis. The only one I know for certain is this one here. And then E, y equals f of x plus 4. That says the original answers won't change, so it'll still have that same shape of answers, but their positions will. What this really says is, at any particular x, I plot the answer that comes from 4 more than it. If I want to plot the answer at 0, I have to go to 0 plus 4 is 4 to find it, and then plot that answer there. In other words, it's been brought back 4. The answer, which would have been 0 at 3 here, to find the new answer at 3, I'd have to go to 7 and take 7's answer and bring it back to. In other words, all these answers are going to go back 4. So that, where would that point be that I would have to reach forward to 0 to get it? Well, at the new position, this new position, x here, I would have to do it such that x plus 4 took me to 0. But the answer is going to say the same 4. So I've got that little equation to solve. In other words, x is going to be negative 4. So that point's going to go to negative 4, 4. Well, they quite often just say it's just the opposite. It's just going to go back 4. So same with the next one. I could just say straight away it's going to go back 4. But strictly speaking, what I'm doing is saying, well, I've had to go forward 4 to reach this position to get its answer to take it back. So where am I going to take it back to? Solve that equation, and the answer will still be 0, of course, that I'm going to carry back with me. I'm going to carry that back to solve that, negative 1, but the answer will still be 0. 6, where's 6's answer going to go? Well, wherever it goes to, I would have had to reach forward 4 to get it. So its position would be x plus 4 took me to 6. So it's going to go to 2, 0. And same with the next one. If x plus 4 takes me up to 9, that means that, taking away the 4, it's going to carry back to 5. It would have been, to find the answer at 5, I'd have had to stretch forward to 9 to pluck its answer and bring it back. But again, the simple way of saying that is, you just do the opposite of what it says because you're solving an equation. And the opposite of what it says means I've got my original answers and I transport them something like this. Like this, where I no longer know where it's cutting this axis. The only points I know are these 3 points of intersection. I'm not going to move this one back here. I could put down its coordinates, but it's not an interesting point. This one, 2 things happening this time. One, there's a change to the answers. The answers are going to be the negative of the original values, so you know that's a turning upside down. And at any particular value, I'm going to have to go to the answer that was 3 times further away and bring it back. So everything's getting crushed up by 3 times and then turned upside down. Or if I wanted to put down what's happening here is this. Where do I find the new answer? Well, 3 times it is 0, and it's going to be the negative of the original, which means my new answer is solving that equation is still at 0. So 0, negative 4. What about this one? 3. If 3 is the position whose answer I'm going to take, then where's it going to go? I'll have to solve 3x equals 3, and 0 would still be 0 when you turn upside down. Solving that equation gives me 1. So that answer is going to go back to 1. And so it should, because to get the answer at 1, I've got to go to 3 times 1 to find it. There it is. It's just a case of reversing it. You just think, how would you solve that equation equal to the number, divide it by 3? So it'll be the same with the other ones. I'm just going to be dividing them by 3. I'll just do that straight away. So dividing by 3 will make that 2. The negative of that is still 0. Dividing by 3 will make that 3. The negative of that will still be 0. You just think all that happens here is it squeezes up to 1/3 of its width, and then you turn it upside down. Like this. Maybe quick to scale properly. Crushed up, turned upside down. So we come to G. The only really interesting one in the exercise because it's got all 4 linear transformations there. And certainly don't look at the back of the book for the answer because that's wrong. It's following a sort of common misconception. Because normally you think, right, what do I do? Ignoring the starting point. 2f minus 1 means double it, take away 1. This certainly doesn't mean divide it by 3 and then take away 2, which is the way they've arrived at the answers at the back of the book. What this says is, to plot my new answers, if I want to plot the answer at 0, then I go to the answer belonging to 3 times 0 plus 2, I go to 2's answer, I take 2's answer, I double it and take away 1 and bring it back to 0. I want to find the value of this new function at x equals 1. What would I do? Well, what I'd have to do is this. I'd have to go to the value of the function at 3 times 1 plus 2 is 5. I'd have to go to 5 and then double it and take away 1 and bring that answer back to 1. So how do you get from 5 back to 1? Is it divide it by 3 and then take away 2? No. Divide it by 3, that's 5/3. Take away 2. That's not going to take you to 1. The way you get back to 1 is by reversing this, by taking away 2 and then dividing by 3, which is completely opposite to the general misconception of it. The way that you get these answers are just by doing what this says. I have to go to this location to find the answer for a particular x. So if I want to know whose answer 0 is holding, I'll have to solve the equation 3x plus 2 equals 0 to find who wants that one. The other part's easy. And once I get its answer, I double it and take away 1, so it's 2 times 4 minus 1. But what that means is, this point's going to be, take the 2 across and subtract it, is negative 2, then divide it by 3, is negative 2/3. And that will be 7. So that point 0, 4 is actually going to go back to negative 2/3, 7. Next one. Who wants 3's answer? Well, whoever it is, it'll be 3 times it plus 2 will give you 3. The answer will then be 2 times 0 minus 1. That bit's easy. That's just the new answer will be negative 1. But where is it going? Solve this equation to find where this would go back to find who wants this answer. Take away 2, that's negative 1. Divide by 3, that's, take away 2 is positive 1, sorry, divide by 3, 1/3. The answer would go to 1/3. If I wanted to plot the answer at 1/3, I would do 3 times it, which is 1, add on 2, which is 3, and seek out the answer for 3. But notice, it's just do this in reverse. Be quite happy saying, well, it's 3 times it, so that means I'll divide by 3. It's add 2, so I'll take away 2. But when you've got both of them together, do it in the correct order. How would you solve that equation? It'd be take away the 2, then divide by the 3. Same with this one. 3x plus 2. Who wants the answer from 6? Take away 2, 4, divide by 3, 4/3, 1 1/3. And what answer will you get? Well, when you go to 6, you'll find it's got an answer of 0, and then amend it that way, 2 times 0 minus 1. So I'll get the answer negative 1 to carry back to 1 1/3 with me. This answer that was at 9. At 9 the answer was 0. Who wants that? Well, the position that wants it says 3x plus 2 should take me up to 9. And once you get there, I'm going to double that answer and take away 1. That's 7 divided by 3. That's 2 1/3. Negative 1. That's what would happen to the answers there. It isn't just a case of do the opposite the same way as you do the external one. It's like solve the equation. Do that in the reverse order. So plotting that then, like this. Of course, all these original points are now off the axis and I don't know anything where it intersects the axis of the turning points. And then for the last one here, y equals the absolute value of f of x. Again, no change to x, so the new answers are plotted at the same position as the old answers. So the answer at 0 will still be found at 0. The answer which was at 3 will still be found at 3. The answer which was at 6 will still be found at 6. The answer which was at 9 will still be found at 9. The only difference is the answers which were there originally will now be the positives of them. Well, they all were, so there's no change to that. So actually using these points doesn't indicate at all what happens with this. It's these other points that would have been more interesting, because what that says is all the negative answers will be replotted as positives. So I'll just alter this graph finally. So that would be fine. It was just that this part that was below here will now bounce above, and this part which was below here will now go above. That would be the graph of the absolute value of f of x. Right, that was question 6.